Well, we have a question here, question 4. The question says the sketch below shows the graph of f of x, 6 over x minus 4 plus 3. The asymptotes of f intersect at A. The graph f intersects the x-axis and y-axis at C and B respectively. Now, question 4.1 says, write down the coordinate of A. As you can see there, the coordinate of A. So A is basically the point over here. Okay, so this point here. So we need to find the coordinate of M. Write the question here, 4.1. So we're looking for the coordinate of A. Well, if you look carefully, A is just excuse me. A is the points at the intersection of the asymptotes of the hyperbola f. Okay, we know that the hyperbola is given over there. This is of the form y equal to A over x minus p plus q. Okay, where p and q are the vertical and horizontal asymptotes. The vertical asymptotes and q is the horizontal asymptotes. Now, in this situation, we can see easily clearly that p is 4, okay, and then q is 3. So now we say that the vertical asymptotes. So A is the point 4 and 3. Thank you. Now the following question says that question 4.2, the question says calculate the coordinate of B. Okay, let's see. B is this point here that lies on a parabola and also intersects the y-axis. By that, we understand that the x-axis is the x-coordinate is 0, so it's the point 0 and y something. Okay. Now let me write here 4.2. Okay, we want the coordinate of B, which is 0, y. Excuse me. So the equation, which is the equation f of x is y, so it can be written as 6 over x minus 4 plus 3. So over here, we'll substitute to x by its value, which is 0. Okay, and then solve for y. We submit the value of x is 0, and then we solve for y. Now this will be y will be equal to 6 over negative 4 plus 3, and then 6 over negative 3 is just negative 3 over 2 plus 3, and then we can write like negative 3 over 2 plus 3. We can just write it 9 over 3, okay, because 9 over 3 is just 3. Excuse me, you can just write it 6 over 2 because 6 over 2 is just 3. And then the idea was to get the sum denominator here in order to work out, to calculate easily the fraction. So this will be negative 3 plus 6 is just 3 over 2. In this situation, we just add the numerator, okay? And then we got the value of y, therefore B is just the point 0, 3 over 2. That's the coordinate of the point B. And then the following question would be then, let me move my board a little bit up there. The following question is question 4.3. Excuse me, question 4.3. The question says calculate the coordinate of C. Okay, and then C is the point over here, which is the x-intercept of the parabola. So, you know, I'm going to write here 4.3 x-int. The x-int is the same, means, okay, let's first write 4.3. We want the point C, which is x 0, because it is the intercept. Now, x-intercept simply implies make a y equal to 0, because we have like y equal to 6 over x minus 4 plus 3. So in this situation, we're going to make y equal to 0. So it's going to be y equal to x minus 4 plus 3. Y becomes 0, and then we're going to solve for x. Okay. Now we can do that if we move the positive 3 over. This will become negative 3 equal to 6 over x minus 4. And then we know that this has like a denominator of 1. And then now we can solve this by cross multiplying. We can do negative 3 times x minus 4, and then 1 times 6. And then this will become negative 3 open bracket x minus 4 close bracket equal to 1 times 6 makes 6, and this will be negative 3x plus 12 equal to 6. And then we can move the 12 over, that makes 6 minus 12, and then this will become negative 3x equal to negative 6, and then we can divide both sides by negative 3, and then we can get x equal to positive 2. Therefore, the point C has coordinates 2, 0. Okay, the x-intercept. We get the point C. And on top of that, we also have like the point question 4.4. The question says calculate the average gradients of f between B and C. So f of x being a hyperbola, which is a curve, it does not have a constant gradient. Okay, what we call the average gradient is like we assume average gradient is like assuming between 2 points, assuming like this was straight line, and then we work out the equation of the gradient, and then to solve in order to solve this. Okay, something like this. Let me just move my board over here. So it's like I'm gonna write here 4.4. The average gradient M_Av. Okay, it's similar. It's similar to say y2 minus y1 over x2 minus x1, but usually it is written like this. M average will be like f of x2 minus f of x1, okay, over x2 minus x1. But those two are the same thing because f of x2 is y2, and then f of x1 is same also as y1. Now we can just substitute from, so the average gradient will be f of x2, which is y2. Okay, okay. It doesn't matter which one is going to be your x1 or x2. So if I take this, my first point, like my second point, so now I'm going to say y2, which is 0 minus y1, 3 over 2. I'll go that way. So it's going to be 0 minus 3 over 2, 0 minus 3 over 2 over x2, which is 2 minus 0 x1, which is 0. And then this would make the average gradient will be negative 3 over 2 over 2. Now M average would be what? Remember that the 2 here can also be written like 2 over 1, okay? Because this is the case of dividing a fraction by another fraction. And then what we do in this situation, we will write the first fraction negative 3 over 2 times by the inverse of the other fraction. And then this make M average will be equal to negative 3/4. So that's the average gradient. Okay. Now, the following question is determine the equation of the line of symmetry of F, which has a positive. It says here. Question 4.5. Determine the equation of line of symmetry of F, which has a positive intercept. Okay. I think I would like to reproduce the same graph over here for better understanding. The rest here 4.5. So we want actually the equation of the line, okay, of symmetry. We know this is a straight line, the line of symmetry. All right, let me just do the diagram here. Okay, this is our graph. Now, the line of symmetry is a straight line, okay? So they are basically the line that passes through the asymptotes, okay? One passes through the asymptotes here, okay? And then the other one will come there and pass through the asymptotes. As you know, the other one will pass through the asymptotes. That those are just sketch graphs, but they're straight lines. Then there are two lines. Now you notice that this descending line, the second line that draws here, this has a negative gradient because it's decreasing. Over here, we have like a negative gradient, and then this one has a positive gradient because the line is increasing. Okay, from left to right is increasing. Here it's decreasing from left to right. So we are concerned about, so we are looking for, basically we're looking for this one, okay? The other thing we need to note that in the line of symmetry, for the line of symmetry, the gradient is always equal to, it's always plus or minus 1, okay? A positive 1 for the increasing line, and then negative 1 for the decreasing line. So we have like y equal to 1x plus c. Now, because it passes through the asymptotes, and the asymptotes, we did find earlier that the asymptotes, the point A, which is the asymptotes, was 4, 3. Because line passes by this point, we can sub the coordinate of that point, okay? 3 for y and then 4 for x in order to find c. So it's going to be like 1x plus c, like that. And then this makes 3 equal to 4 plus c. And then okay, hold on a second. What the question says here. Oh, we were about to make a mistake. The question didn't say which has a positive gradient, but the question says which has a positive y-intercept. Oh la la, a positive y-intercept. So if I look at the question here, this one, though it has a positive gradient, its y-intercept is negative. Okay, so it's not the plan that we're looking for. We're looking for this one, okay, with a negative, with a positive y-intercept. So we are basically looking for this line here with a negative gradient. So it is the one that has a negative, so a negative 1 there, negative 1x plus c. So this would be 3 equal to negative 1 times 4 plus c. That makes negative 4 plus c. And then if you move the negative 4 over, that makes 3 plus 4 equal to c. And then that means c equal to 7. Therefore, the equation of the line will be negative 1x, which is just negative x, plus 7. That's the equation of that's the equation of the line. Oh, something was wrong, but okay, anyway, but this is the equation of the line passing through A, and that has a positive y-intercept. Well, thank you.